Now I want to move into describing matter, and we're going to start by talking about the difference between chemical and physical. So when we talk about matter, one of the main things we do is we talk about the properties of our sample of matter. And every property is the answer to a question about that sample of matter. How big is it? What sound does it make when you hit it? What's the phase of matter? Solid, liquid, gas. Can light pass through it? Is it a mixture or a substance? Is it flammable? All of these sorts. Whenever you have a question, the answer about a sample of matter, the answer to that question is a property of that sample of matter. So when we get into these, we actually want to, before we get into properties, we want to talk about changes. And so matter can undergo different kinds of changes, first being a chemical reaction or chemical change. So in a chemical reaction or chemical change, at least one substance changes into another substance. So what that means is at least one substance is consumed, it no longer exists, and one or more other substances are produced. So chemical changes tend to not be reversible without further chemical reaction. They are not reversible without further chemical reaction. So for example, this fire that's underlying the grill, you have propane burning in oxygen. Those are two substances. They react, okay, and they become water and carbon dioxide. Those are new substances. After this chemical reaction, the propane and oxygen are gone, and water and carbon dioxide now exist. Okay, you did not have water and carbon dioxide initially, and now you do. So you have consumed the propane and oxygen, and you have produced water and carbon dioxide. Physical changes are any change where there's no change in the identity of a substance. Okay, the appearance of your sample of matter may change, but what it is made up of is not. The distribution of atoms, what substances you have, remain unchanged. Physical changes are generally defined as being more reversible. They're easier to undo. So for example, if you take a pill, and then you smash it up and you get the powder. Okay, so you've taken it, you've just changed its shape. You haven't changed what is in the pill, you've just turned it into a powder. You could reform the tablet by just smushing it all back together. If you stretch a rubber band out, still the same rubber band, it's just been stretched out. And in order to return it to its original shape, all you need to do is let go of the rubber band. It's very easy to undo, you're just affecting the shape. An important class of physical changes are the phase changes. If you have, say, a piece of solid water, which we call ice, and you let it melt, it just becomes liquid water. But importantly, it is still water. You have not changed the actual substance that's involved. You could undo this change just by making your water cold again and get it back to solid. Similarly, boiling water, going from a liquid to a gas, is also going to be a phase change. That is a physical change. So this is a common thing that trips people up. We always want to remember phase changes, always physical. When we're changing phases, we're not changing the substance, right? It's reversible. You could have solid bromine, turn it into liquid, turn it into gas, go back and forth as you see fit, and you can control that just by changing the temperature. So we want to be able to observationally see a change and be able to kind of characterize what it is. Is it chemical or is it physical? Because we want to know, are we making new substances? And so when we're looking at it, it's really kind of going to be, we want to look for signs of chemical change. When we're doing a chemical change, when we're changing the substance, there tends to be more aggressive or visible changes involved, and they're more drastic. And so really we kind of look for, is it a chemical change? And if not, it's going to be physical. So our signs of chemical change, we have a couple of them. First is changes in temperature. Does the process make the area around it warmer or colder? So burning wood is very much so a chemical change. Fire in general is always a sign of chemical change. Is there a cold pack, right? Or something like that, where you say you break something, you start a chemical reaction, and it turns the surroundings cold. It doesn't have to be hot. You're just affecting the temperature around you. Changes in color. If you started with, say, for example, silvery gray iron, and then you let it rust, it turns orange-red. That is a new color because rust is a new substance. It's no longer iron, it's now iron oxide. It's a new substance with new properties. That's why the color changes, because there's new properties. Do you take two liquids and when you pour them together form a solid? Now, importantly, taking, say, liquid water and freezing it is still going to be physical. The thing is here, you're not affecting the temperature. You just have, say, a liquid and another liquid. These are, say, mixtures. And when you combine them together, boom, all of a sudden, you get this yellow solid. There's a color change, but you could also make a white solid, anything like that, where you see this formation of solid that comes about just by mixing liquids. You're not necessarily doing any sort of change or anything like that, and you see this formation of solid. Similarly, if you mix two things together and you see a formation of bubbles, that is a surefire sign of chemical reaction. If you boil liquid, you're putting in heat. You're trying to drive that phase change. That's not chemical. Here, I just have, say, a piece of metal. I drop it into an acid, and then all of a sudden, bubbles start to form on the surface of this piece of metal, right? I haven't put in heat. I haven't done anything. I've just taken two substances and put them into contact, right? These two substances are now in physical contact, and bubbles start to form, and say some heat starts to form. Those are all signs of chemical change. Let's look at some examples then. We're going to classify each of the following as a chemical or physical change. So, biting an apple. If we think that you have an apple, you bite into it, you now have two pieces of apple. You haven't changed what it is, that's going to be physical. Your stomach digesting an apple, though, now that's a process where something more is happening. After your stomach digests it, it's no longer an apple. It has a new name. You've broken it down into all the different components that help you run as, an organism. But you've changed what it is. It's no longer called apple, and so that would be a chemical change. So a trickier one, the condensation of methanol vapor. That sounds very chemically, right? There's a lot of words in there that sound very technical. But those technical language, methanol is a compound. Vapor means gas. And then, so you're dealing with the gas of a liquid and then gas coming off a liquid, and then condensation is just the name for a phase change. Condensation is going from gas to liquid. So steam condenses, like when you get, say, water condensing on, say, a cold glass. That is just a phase change. That's going to be physical as well. So our answers were, let's write them out. It's physical, that's chemical, that's physical. This idea of chemical versus physical then lets us inform properties. So we have physical properties and chemical properties. And chemical properties are a bit more straightforward, a bit more clean. It's the description of all the chemical reactions a substance undergoes. So if you have a substance, any of the chemical reactions involving that substance. It's important to note they can be reactions that the substance doesn't do, right? A resistance to reactivity. This sample doesn't light on fire, those sorts of things. And so that would be any sort of description related to chemical reactions. So then your physical properties are basically everything else. Any characteristic of matter that doesn't involve that substance changing into another substance. So you have a very strict definition on what a chemical property is, and then it's very catch-all for physical properties. It's everything else. So if we want to apply that, we want to determine if each of these describes a chemical or physical property. So I've got a list of all some properties here. And we want to start, is one substance being transformed into another substance, right? That is what implies that it's a chemical property. Because really, physical property is just going to be everything else. Is the change reversible is a nice kind of indication that we're dealing with chemical as well. We're looking for those signals. Is this a chemical change? Can we undo it? So water boils at 212 degrees Fahrenheit. We want to key in on the fact that that is boiling. Boiling is a phase change. You're just saying the temperature that a phase change happens at. That's going to be a physical property. It is a change, but the water is boiling. It's just becoming gas phase water. It's still water. You don't have a new substance. Zinc metal is a bluish white metal. Bluish white metal. Bluish white is the property, it's a color. Metal is a type of material that you're dealing with. But it's just a description of zinc. There's nothing about zinc changing. So that's going to also be physical. Zinc doesn't change. It starts as zinc. You're just describing what zinc looks like. There's no change happening at all. That has to be a physical change. When zinc is added to an acid solution, bubbles form. Okay, when zinc is added to an acid solution, bubbles form. One of the things we can key in on is bubbles form. We know that bubbles forming, especially when you're not adding heat, is indicative of a chemical change. So this is in fact chemical. Well, the other thing we can key in on is that what's causing the bubbles to form is zinc being added to an acid. So we can see there are two things involved. It's a property of when you mix zinc with something else, when you combine it with something else, when you expose it to something else, something happens. So those are good indicators of this is a change that's about changing substances and that there is going to be a chemical process. Zinc powder burns, that's chemical. But again, it burns in air, that same idea. There's something else involved here. That's the sign that it's going to be a chemical change. Zinc conducts electricity. This one can be kind of tricky. You know, you run current through it, but you're doing something to the zinc and electricity flows through it. But then if we think about afterwards, you still just have zinc. So conductivity is going to be a physical change. A sample of seawater is 3.4 gallons. There is no change at all. That's just the size of your sample of seawater. That's a volume. Volume measurements are always physical. Water is not flammable. This is a tricky one. We have, whenever we see flammable, flames, anything like that, that would be a chemical change if water lit on fire. Because you're still talking about it not doing a chemical change, that's going to be, whoopsies, a chemical property. Okay, sorry for erasing the other one. That's going to be a chemical property. So water not being flammable is still a chemical property. Because flammability would be a chemical property, not being flammable would still be a chemical property. You're talking about all of the things water does and doesn't do. This is a really important chemical property of water. It's why firefighters use it to fight fires, because it is not flammable. A liquid is bromine. This is just the name. A liquid is bromine is a chemical name, but as far as property goes, names are physical.